Hello students, once again you're welcome to this course. Hello students, once again you're welcome to this course, Network Session Management by Professor Abdulwahab Eedriss in Waidsum University. Here, our topic for today is we're in chapter 7, part 5, and our topic for today is configuring the network interface. Configuring the network interface using what we call the auto negotiation method. Using the auto negotiation technology, okay, to configure the network. You know, in chapter 7, part 4, we talked about how to configure the router interface. Now, we're describing how to configure the network interface. Okay, to configure the network interface using auto negotiation. Now, the first and foremost regarding auto negotiation, when we talk about auto negotiation, we first of all look at the devices in a network that use this capability or this technology. We say most of our networking or our internetworking technologies that we have, all the networking internetworking technologies like your hub, your switches, your bridge, your routers, now they use what we call the auto negotiation protocol. So the protocol they use is called auto negotiation. Most of the internetworking the technologies that we have today, like our hubs, our switches, our bridges, our routers, they all use what we call the auto negotiation protocols. Is that okay? Now, this protocol, what it does is that it enables the Ethernet equipment to automate many of the installation steps by itself. It automates many of the installation steps. Okay, you know, normally in installation we do it step by step, right? So, but this auto negotiation enables the Ethernet equipment, all your hub, your switches, your router, your bridges, they're called the Ethernet equipments. Okay, it enables them to automate all the installation steps. And what this means is that it enables them to automatically configure the operating speeds without you setting or configuring the speed, writing the code for speed configuration. It enables them to automatically configure the operating speed of these hardwares. For example, it can between the speed available, like the 10 megabit per second, 100 megabit per second, and 1000 megabit per second, which is 1 gigabit per second. This auto negotiation protocol, it's a way, or it's a technology that is developed to enable the internetworking technologies to automate the speed, automate and configure their operating speed by themselves without us selecting anything. Okay, the only thing we do is the selection of the full or the half duplex operation for the data leak. Okay, so the auto negotiation protocol is able to automate the speed by itself. It's able to select the kind of speed that the internetworking technologies we use. And when we say internetworking technology, we're referring to the hubs, the switches, the bridges, and the routers. So once they're able to configure the speed, they're also able to select what mode for data leak, upload or download. What mode will it be? Will it be a full duplex or a half duplex? Now, the auto negotiation protocol is defined in the IEEE Ethernet standard of 802.3x for fast Ethernet. It's specifically used for fast Ethernet. Okay, it's already defined in IEEE. IEEE is Institute of Electrical Electronics Engineering, like an organization for publications and setting standard for anything that has to do with electrical, telecommunication, electronics. Okay, so one of the standard, the IEEE Ethernet standard for fast Ethernet and for auto negotiation, is the 802.3x, okay, which is used for fast Ethernet. Now let's take a look at what we call the fast link pause, because the auto negotiation uses what we call the fast link pause. So the auto negotiation protocol uses what we call the fast link pause, FLP. What they use it for is to carry the information between each end of a data leak, from one end of a data leak to another end of a data leak. That's what they use this fast link pause to do. Okay. Now the data rate for the fast link pause is usually 10 megabit per seconds. Okay, which is same as 10 base T. Whenever we say 10 base T, it means we're referring to 10 megabit per second. Okay. Now the fast link pause, we remember we said the auto negotiation protocols, they use what we call the fast link pause. Now these fast link pauses are designed to operate over a limited bandwidth, not so much a big bandwidth, a limited bandwidth, and they support CAT3. CAT3, remember we studied this in chapter 1 or chapter 2 of this course. Okay, they're supported by limited bandwidth, not so much big bandwidth, and they are supported with CAT3 category. CAT3 means category 3 cable. Okay, so which means the pause just requires little bandwidth to send the signal across, and it uses category 3 cable. Hence, if a link is negotiated between two devices, it could be your computer and a hub, or a computer and a switch. If a link is negotiated between two devices on the network, then there will be no guarantee that the negotiated data rate will walk over the link. No guarantee, because this is automated. It's just by itself. There is no guarantee that the automated data will walk over the link that has been created. So in order for us to have a guarantee, like a surety, to relax our mind that the link that has been auto-negotiated by our system, operating systems, or by the networking internet-networking devices, this link that has been created is this link that has been created by the networking internet-networking devices, we have to carry out some other things to have the confidence, to gain the confidence that whatever we have, we walk over this link. Whatever data we're going to transmit or receive through this link is going to work perfectly. So one of the other tests, we have to carry out some other tests. One of the tests we do carry out is to test the cable leak. We must use it to satisfy whether the cable can carry the negotiated data link configuration that we have. So this we talked about the cable. We studied cable in chapter 2, right? We had detailed study the testing of cabling. We did this in chapter 2. So you must test the cable link. You must test the cable link, and you must be able to use to satisfy whether the cable can carry the negotiated data link. Okay. So not only when it's auto-negotiated, then we feel like the job is done. We must do some cable testing. So you must carry out other tests on cable to ensure that this link is perfect for data transmission and data reception. Now let's take another subhead, the auto-negotiation itself. Now let's take a look at what we're talking about when we say auto-negotiation. Here, you see a partner link. When we talk about auto-negotiation, we talk about two or more devices, okay? One advertising whatever it has, its capability, and the other one responding by saying, yes, I have it, I can support what you have or what you're about to give, bring it on. Okay, whatever you have, my link or my system can support it, so bring it on. So each link partner shares or advertises its data link capability with the other partner. So this computer will advertise. This computer will advertise its capability, the data link capability that it has over this. It creates a link and advertise it with this switch. Okay, we'll advertise with the switch. Now the switch will also advertise what it has, whether it can support the data capability of this computer, because this computer will advertise its data capability over this link. Okay, it will advertise it, and then every other device on the system, whoever can support whatever this guy has advertised, this computer has advertised, because the computer has just advertised its data capability, data link capability. So maybe probably it has advertised 10 megabit per second speed, and then this switch say, oh, bring it on, I have 10 megabits per second switch, I also have 100 megabit per second switch, so you can send to me, I have the capability. So this is what we call auto negotiation. This one advertises the data leak capability, and the switch also advertises what it has, if it's able to support it or not. So if what it has is able to support it, support what the computer is sending or is advertising, then a link will be created between the two devices on the network. A link will be created between these two devices on the network. The two link partners, they use the advertised capability to establish the fastest possible data link rate for both links. They establish the fastest, what will be the fastest between the two links. Now let's take a look at an example. Now in the example of the auto link partner that we are just describing, computer 1 advertises that its interface supports 10 base T, that's 10 megabit per second. So what this computer is advertising, it's actually showing that its capability can support a speed of 10 megabit per second. So it advertises over this, and then the switch is going to respond. The switch will also advertise something, because both devices will have to advertise what they have. So the switch advertises that it supports both the 10 base T and the 100 base TX. 100 base TX means 100 megabit per second, and 10 base T means 10 megabit per second. So this switch is saying, oh, you can bring it on, because I can support both 10 base T and 100 base TX, okay, or 10 megabit per second and 100 megabit. So the switch can support both the speed of 10 and the speed of 100. So it advertises what it can do, and then this computer sees it, and then a link is created between them. This process is called auto negotiation. This scenario, this characterization, or this characteristics is called auto negotiation. It's a process whereby a computer or a device on a network advertises its data leak capability. A process whereby a device on a network advertises its data leak capability, and the corresponding link partner also advertises its data leak capability, and hence establishes a link if both of them are compatible. Establishes a link if both of them are compatible. Such is called auto negotiation. This kind of characterization is called auto negotiation. And still on auto negotiation, you can see the computer is a link partner. So each of the devices is a link partner, and this is also a link partner. So hence a link will be created. The network interfaces on each link partner are set for auto negotiation. Because why are they set for auto negotiation? Because what computer has advertised, the switch can support. The switch has also advertised what it has, so they can support both themselves. So once that is done, a link will be set up. Once both devices has or can support each other, a link will be set up. So we say the network interfaces on each link partner sets for auto negotiation. Therefore, the 10 base T operating mode is selected. The 10 base T operating mode is selected. Why? Because why do we select the 10 base T operating mode? Because this capability, the capability of this computer is 10 base T, And the switch has both 10 base T and 100 base TX. So since this computer and this one, they want to partner together, and this computer only has 10 base T capability, then this switch has to adopt, because the switch has both the 10 base T and the 100 base TX. So the switch has to use its own 10 base T to correspond with this one. Whatever this one sends, the link has to accept with the 10 base T. So this is the fastest data rate that can be sent. What this means is that between these two, the fastest data rate that can be sent through this link is the 10 megabit per second. The highest speed of sending data between these two devices on the network is 10 megabit per second. Remember, 10 megabit per second means 10 base T. Okay, so the highest speed capability between these two devices has already been established. This link has already been established as a result of due to the process called auto negotiation. And now that this link is established, then all the speed of the data transmission the highest will only be 10 megabit per second, because that's what this computer has if we advertised in the first place. So auto negotiation takes place when an Ethernet link is established. When the link is already established, then we can now say auto negotiation has just taken place. Okay, if a link is never established between two devices, then there is never auto negotiation. It's only the final stage when the link has been established between this computer, this link partner called this computer, and the switch, and then we can say that auto negotiation has been established. The link information is always sent one time. This is only one time, not like repeatedly or continuously. It's only this link, once it's established, it stays for them for a while. Okay, so it's only sent one time, and when the link is established, that's it. Okay, the negotiated link configuration will remain until the link is broken or the interfaces are reconfigured. Now, the only time they auto negotiate a link between themselves is when this link is broken, or when the interface, you want to reconfigure the interface. Okay, you decide to reconfigure the interface. That's when you lose this link between this computer and the switch. If not, it stays. So it can be used repeatedly as many times as possible. Now let's talk about the mode of transmission and reception of data in a link. Okay, when auto negotiation has been set up, then we have to look at how data will be transmitted or received in a link. Okay, so there are two ways. The first one is full duplex mode of transmission, and then the second one is the half duplex. Okay, but however, one thing to note is that modern network interfaces, like all your computer networking interfaces, from your hub, from your switch, from your bridges, from your router, all of them that are used in your network, they have the capability of running the data over the link in either full duplex mode or running it in half duplex mode. So each of these modes, every of these new technologies by Hawaii, Hawaii, Cisco, Hawaii, they manufacture the one that Hawaii that is making phone in China. They also manufacture networking devices. They manufacture hubs, switches, routers, bridges, and all of these things. So they manufacture telecommunication electronics equipment. Okay, so most of the new one, either made by Cisco or made by Hawaii, they actually can support both the full duplex mode transmission or reception or half duplex mode. Okay, we're going to now look at the differences between a full duplex mode for transmitting data in a data link and a half duplex mode. Now, a full duplex mode means the communication means that the communications or the communication devices on the network can transmit and receive data at the same time. So all the communication devices, all your networking devices, all your telecommunication devices, your networking devices, your communication devices on your network can transmit and receive data at the same time. That's the meaning of that's the meaning of full duplex mode. Transmit and receive same time, doesn't matter. A can send to B, B can send to A same time simultaneously. When this happens simultaneous, when there's simultaneous transmission and reception, we say this mode is called a full duplex mode. A simultaneous transmission of data in a link between two devices on a network is called a full duplex mode. Concurrently, when the transmission and reception is happening concurrently or simultaneously, then we say that the type of link established or the type of transmission method is a full duplex mode. Now, for half duplex mode does not mean that it's half. What it means that the mode means that all your communication devices or your telecommunication devices on a network can transmit or receive, but one at a time. They cannot do it at the same time. So when the system is transmitting, then reception have to wait. When it's receiving, transmission has to wait. So one at a time. They cannot do it simultaneously. It's like simple equation, simple linear equation. Okay, why this one is like simultaneous equation? The full duplex mode is like simultaneous equation, while the half duplex mode is like just a simple equation. Is that okay? So let's move on. Now let's take a look at the full duplex and half duplex. The first one is the 100 base T. In a full duplex operation, the media, that's the whatever you use, the device you use, the media must have separate transmit and receive data path. You must have port, either port, P-O-R-T, port or pins for transmission, for reception in a full duplex mode. So you all your 8 pins cannot be like transmit, receive. So they must be different. They must be different. You have pins for transmission, pins for reception. Okay, so that's what we mean. In full duplex mode or full duplex operation, the media must have separate transmit and separate receive data path. Okay, just like you have on this table, just like we have on this table. Okay, this is a 100 base T signals with pairs 1, 2 is for transmit. Look at pin 1 and pin 2. These are for transmit. Pin 1 and 2 for transmit. You can see transmit. Okay, the direction is given. Okay, the direction is given. Transmit D1. Okay, so pin 3, if you look at this one, is P3, receive is P3 and pin 6 to receive. So to receive, you can see is pin 3 and pin 6 to receive. Okay, pin 5 and 6 are bidirectional, and pin 7 and 8 are also bidirectional. Bidirectional D3 and bidirectional D4. So transmit, receive. Transmit is pin 1 and 2. Receive is pin 3 and pin 6. Okay, so this is an example of a 100 base T for a full duplex mode. A 100 base T for a full duplex mode system. Or your hub, assuming we're looking at the 8 pin in a hub or in a switch, for example, in a switch or a router. We're looking at 8 pin. Pin 1 and 2 is to transmit data. Pin 3 and 6 is to receive data. Pin 4 and 5 is for bidirectional, for other functions, and 7 and 8 same other functions. So then in the 1000 base T application, the bidirectional data for full duplex operation is provided. So if you are now taking a look at the 1000 base T, everything is bidirectional. Everything, all the pin will be transmitted bidirectional. Anyway, okay, it will go come same way. So you can use any of the pin. You remember the one we just talked about just now was for 100 base T, but when you increase the operating speed, then they are all bidirectional. They are all pin 1, 2, 3, 4. Any of them can be used to transmit, and any of them can be used to receive. That's what we mean by bidirectional. Okay. Now, also something to note when we're looking at full duplex and half duplex for transmission is that the full duplex mode in computer networks link is only for point-to-point link only. Remember this. This is very important. Okay. Remember this. The full duplex mode is only for point to point. We say the full duplex mode in computer network links is only for point to point links. What this means is that there can only be two end stations on the link. You can only have two end stations on the link. Okay, this CS carrier sense multiple access. The CS CD protocol is turned off when you are using this type of point-to-point link for a full duplex mode. You turn off the CSMA CD carrier detection. CD is carrier detection. Okay, carrier sense multiple access, or you call it carrier detection protocol, is turned off when you are using a full duplex mode. So why? The reason is that so that there will be any another networking device competing for the use of the link. That's the reason why we have to turn off this CSMA protocol. You turn it off. If you don't turn it off, then other devices on the network will compete for the same thing. So once you turn it off, only those whose link is established will be using this link at this point in time. So an example of networking device that can run full duplex are computers connected to a switch. So if you're looking for devices that can run full duplex, a good examples of devices that can run full duplex are computers that are connected to a switch in a network, not to a hub. Okay, usually to a hub is half duplex. Computer connected to a switch can run a full duplex on a network. The switch can be configured to run the full duplex mode. Okay, that's why. Okay, we can configure the switch to run a full duplex mode. So, however, this also requires that each end station of the link must be configurable to run a full duplex mode. So, whether the computer must be configurable to run a full duplex mode, okay, it must not be like very old computers of the 2000. Yeah, 2000 cannot. You have to buy modern computers with the racer capabilities and speed and storage and all of these things. So this shows that all the two devices that have established that link must be able to run on full duplex mode, or must be able to be configured to run on a full duplex mode. Now let's take a look at diagram to illustrate or to show what we mean by full duplex mode. If you look at this, here is a switch. Okay, here is computer 1, computer 2, and a switch between them. And then this is for a full duplex mode. This is for a full duplex mode transmission and reception. Full duplex mode. Okay, then the second one, the B, the first one is A. The second one, the B, is called half duplex. If you look at this diagram, the A is full duplex. And you see we're using modern computers with a switch. Okay, in the half duplex, let's start with the half duplex. In half duplex operation, the link uses the CSMA-CD protocol. For this one, the link uses it, the CSMA protocol or the CD protocol. This means that only one device talk at a time, and while the other device is talking, the other networking devices just listen to the network traffic. One is talking, let's say computer 1 is talking, okay, to the hub and receiving from the hub, but this one, the other computer is just listening, cannot transmit. Okay, cannot transmit. So this is called half duplex mode. And even the one that is sending, it will send and wait. Then the hub will reply to this computer. This other computer will just have to listen. His job is just to listen to the network traffic till he sees that this one the network is no more busy. If the network is not busy, then he can send. He can send in a half duplex mode. But in a full duplex mode of operation, the CSMA-CD is turned off. You turn off the CSMA so that it cannot listen. no one will listen to each other. You send, I send, you send, I send. You know, in A, we turned off the CSMA. We turn on. We turn on in half duplex mode. The CSMA CD protocol is turned on, so that this computer too can listen while this one is transmitting and receiving from the hub. So the only thing it does is to listen in a half duplex mode. However, in a full duplex mode, we turn off we off it. We turn off the CSMA CD protocol. The reason is that so that no one will listen. You send, I send, you're busy, I'm busy. Okay? So my job does not affect you. So CMS is turned off for full duplex mode. The CSMA CD protocol is turned off, and computer 1 and 2 and the switch are transmitting and receiving at the same time. This computer transmit to the switch, receive from the switch. Computer 1 transmit to the switch, receive from the switch. Computer 2 is doing the same thing at the same time, transmitting to the switch, receiving from the switch. So this mode of transmission and reception is called a full duplex mode of transmission. Okay, it's called a full duplex mode. In half duplex mode in B, half duplex in B, the CSMA is turned on. Why we turn it on for half duplex? So that one computer has to listen. So computer 1 is transmitting and computer 2 is listening or receiving the data transmission. Is either it's listening or it's just receiving the data. That's it. It's listening and just receiving the data. Okay, that's all it's doing. It cannot transmit, it has to listen. Only when this one is no more transmitting, then computer 2 can now transmit. That's half duplex mode. So I hope this gives a good clarity on the mode of operation that we have in network. Okay, so port management, another subheading in this is port management. An example of port management option available with Cisco switch is the speed auto 10 auto 100 megabit per second duplex auto half and full negotiation. So these are, because you are managing them, the auto negotiation for speed 10 megabit per second, 100 megabits per second, whether you are using the duplex and the half duplex, all of these are called the port management, because you are managing every port as the transmission is taking place. Now let's talk about the advantages of this sub chapter of carrying out auto negotiation, or of configuring the interfaces on the network. One of the advantages is, or the benefit or the usefulness, that it's useful in LAN. Okay, auto negotiation is useful in LAN, or configuring a network is network interface is useful in local area network that have multiple users with multiple connection capability, because different users have their different connection capability. So establishing a link between two devices on the network is very paramount. Okay, so that we know if they can communicate or they can transmit and receive among themselves. Then another advantage is that the auto negotiation feature can maximize the data link throughput. The data link throughput, that's the speed and the capability of the capacity of the network. Okay, there will be no redundancy and we reduce wastage on the system. Okay, these are the two big advantages from establishing an auto negotiate a link between two devices on a network. Now let's take a look at their disadvantages. Okay, we say one of the disadvantages is that this is not recommended for fixed data links. Remember, it's for point to point. This is not recommended for fixed data links such as the backbone in the network. So for this system is not recommended for any backbone in a system. Okay, a failed negotiation on a functioning link can cause a link failure also. So if the negotiation failed, even if the link is functioning, then the whole link might fail. So this is another disadvantage. So with this, we've come to the end of our today's chapter. Thank you for